Well, welcome back to another exciting night. Today we start the new world of probability. So hopefully that word sounds familiar to you before. Maybe you're thinking, what's the probability that I win the lottery? What are the odds that something happens? And that's what we're going to start talking about. So we're just going to start by going through some definitions that we need to be familiar with. The first one is probability itself. So when I think of probability, in my head I'm saying, how likely is an event to occur? Experiment is another keyword, and I would say this is just a process that occurs. And then, of course, you have an outcome. After you have an experiment, you have results, an outcome. I would say an outcome is a result from a single trial of the experiment. Just a few more keywords. An event is a collection of one or more outcomes. And then lastly, a sample space. A sample space is a collection of all of the outcomes from an experiment. So let's take a look at this first example. An experiment is run whereby a spinner is spun around a circle with 7 equal sectors. So can you picture doing this? You're just spinning this little spinner off to the side, maybe in a game you played when you were younger, maybe in a game you played last night. But you're just spinning the spinner. So what is the experiment? Well, remember, the experiment is just the process that occurs. Well, what process is happening? I think it's pretty straightforward. You are just spinning a spinner. Okay, part B. Describe an outcome of the experiment. So if you look back in your notes there, an outcome is just a result from a single just a result from a single trial. So if you were to spin this spinner, what's one result that could happen? I could land on the number 1. So there is an outcome. Now, certainly that's not the only outcome. You could land on the number 7. You could land on the number 5. Okay, so I'm just saying describe any outcome that could happen. So any result. Part C. What is the probability of spinning the spinner and landing on an odd number? Now, you probably know enough about probability before we get too far into it to answer this question. What is the probability of spinning the spinner and landing on an odd number? Well, if I take a look at this, I'm thinking, let's see, 1 is odd, 3, 5, and 7. So I wonder if you're saying the same thing. I'm saying that's 4 out of 8, or equivalent to 1/2. Now, I want to represent that number several different ways. In probability, we can express our answers as fractions, decimals, or percents. So you probably know 1/2 is equivalent to 0.5. So I could say 1/2, 0.5, there's my fraction, my decimal. And if I want to change 0.5 to a percent, remember you just move the decimal 2 places to the left. So my other option would be to say 50%. So we've kind of already answered the next question, but we'll just spell it out a little clearer. What is the event? Well, the event is that you land on an odd number in this question. So land on an odd number. That was the event that we were looking for to occur. Now, what outcomes fall into the event? Well, a lot of times in probability, when we talk about an event, we're going to put an uppercase E, and we'll just list the outcomes. What are the odd numbers? Well, again, we had already circled them. 1, 3, 5, and 7. So you'll see a lot of this terminology, and I'll try to just keep reviewing it for you. But the event is just what we wanted to happen, and then we just listed the outcomes that could happen. So here's our formal definition of probability, so let's get this neatly in our notebook. The probability an event E will occur. So here's our notation. P of E equals lowercase n of E over n of S. And I'll explain what these mean. The n of E is the total number of outcomes that fall into event E, and n of S is the total number of outcomes that fall into the sample space. Now, I just want to remind you that probability can be written three ways. So let's be very clear. We can write it as a decimal, a fraction, or thirdly, as a percent. And I just want to talk about the range of probability. Okay, let's draw a number line here. All probabilities are going to fall between 0 and 1. Okay, you can't have a negative probability. If you know something is never going to happen, for example, when pigs fly, that would be a 0 probability. It will never happen. Okay, if you know something is certain to happen, we would say it has a probability of 1. Okay, if it must happen. And basically anything else is going to fall between. There's a 50% chance it'll rain today. Well, that's right smack in the middle between 0 and 1. If I wanted to write 0 as a percent, obviously that's just 0%. If I wanted to write 1 as a percent, that's 100%. And everything falls between 0 and 1. So obviously a half would be smack in the middle, which is equivalent to 0.5 or 50%. 0.25 would fall here, which is a quarter or 25%. But all probability has to fall between 0 and 1. So with that in mind of all probability falling between 0 and 1, consider these questions. If the probability that I draw a red marble is 3 out of 7, what is the probability that I won't draw a red marble? Okay, well, if 3 out of 17 is drawing a red, 100% would be what out of what? Well, that would of course be 17 out of 17. So if it happens 3 out of 17, out of a total of 17 out of 17, the probability that I won't draw a red would be 14 out of 17. Just make sure these two total your amount. Part B, if the probability that it will rain tomorrow is 20%, what is the probability that it won't rain tomorrow? Well, when I'm talking percent, a certain amount would be 100%. So if it's probability that 20% it will rain, the probability that it won't rain, hopefully you've guessed it, is 80%. Let me throw one more at you in decimal version. Question C. Let's say the probability that school is closed tomorrow is 0.02. What is the probability that school won't be closed tomorrow? Well, remember, when I'm talking a decimal, I'm talking about it away from the number 1. So I'm just going to do 1 minus 0.02, which I would say is 0.98. So again, just keep in mind, when you think probability, if it's certain to happen, it's a 1. That's the highest it could ever be. The number 1, 100%. And if it can't happen, obviously a 0. Our next example. A fair coin is flipped 3 times, and the result is noted. Draw a tree diagram to show all of the outcomes in the sample space. So I'm not sure how familiar you are with tree diagrams, but I'll show you how we draw them here. We're going to start with a basic stem. So everything's going to come off this one main stem. So I'm going to flip a coin 3 times, and I'm basically just going to list out my outcomes. So again, this tree diagram just shows outcomes. So when I do my first flip, so I'm going to put a first at the top. Okay, so basically I'm going to line things up, these imaginary dots, pretend they're not there, but I'm just saying this is what can fall in the first column. I can either get a head on my flip, or I can get a tail. And again, I'm just putting those under first because my first flip, I can either get a head or a tail. Okay, now I'm going to flip the coin again because it says we're doing it 3 times. So on my second flip, so let's say my first flip was a head. Now I take the coin and I flip it again. What could you get? What could an outcome be? Well, again, you can get a heads or a tails. Let's say when you flipped the coin the first time, you got a tail the first time. Now the second time you flip, again, you can get a heads or a tails. And now we're going to flip the coin one more time. So let's say the first flip was a head, the second flip was a head, you flip it again, and you still can either get a heads or a tail. Basically, every time you flip a coin, you're either going to get a heads or a tail. So off each one of these comes a heads or a tail. So now I'm going to list out my sample space. And remember, my sample space is just the collection of all the outcomes. So follow my tree. From my first flip, I could get a head, and then a head. So there's one result. Head, head, head. Or I could have got a head, and then a tail. Okay, so just follow the tree. I could have got a head, a tail, and a head, or a head, a tail, and a tail. And then again, I'm just following. I could go tails, head, head, or tails, head, tails, 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 head, tails, tails, tails. And I'm just going to list out the sample space. Okay, so again, this tree showed my different outcomes, but my final collection here is called the sample space. So here's our first question. What is the probability, so that's what this capital P stands for, probability, make a note to yourself, that they're all heads. So you just kind of look at your sample space once it's written out. How many times did you get all heads? Well, I think that's just one. Now, one out of how many? We'll just count them up. 1, 2, 3, 4, 5, 6, 7, 8. That last row should give you the total amount. So I would say that's 1 out of 8 if I wanted it as a fraction. So just to be clear, we're going to write it 3 ways. So I could also say that's 0.125. So there's my decimal. And if I wanted it as the percent, I would say that could happen 12.5%. Okay. Part B, the probability that you get exactly 2 heads. So that doesn't mean you can have 3, and that doesn't mean you can have 1. You have to have exactly 2. So you carefully have to scan here, and I'm going to circle. Let's see. This bear has exactly 2. That one has exactly 2. That has exactly 2. I think that's it. So I would say that's a total of 3 out of 8. Okay, so again, I could leave it as 3 out of 8. I could call that 0.375, just 3 divided by 8, or 37.5%. Lastly, question C. What is the P for probability? Remember, probability of all heads or all tails. So as I'm scanning this time, I need to see 3 H's or 3 T's. So I'm going to circle, whoops, in purple now. I would say I see 3 H's there and 3 T's here. So the probability of either all heads or all tails, I would just say is 2 out of 8. Which is, of course, 1/4, 0.25, or 25%. All right, in our last example here, a survey was done by a marketing company to determine which pop was preferred by people in a blind taste test. The results are shown below. So can you kind of picture this? I've seen TV commercials of it where they show you they have people taste a couple different things and they ask which was the name brand, or can you tell, can you not tell? Same idea. That's what a blind taste test is. You don't know what you're tasting. So question A, find the probability that a person would prefer Pop C. Express your answer in 3 different ways. All right, so I've got a table. That's how this is set up. And these are just referred to as cells. Cell 1 here with its corresponding B11, C24. My total is 53. So I have soda labeled A, B, and C. Again, it's blind. You don't know if it's Pepsi, Coke, Dr. Pepper. And the number who preferred each one. So I want to know who preferred Pop C. Well, I can say, well, that is certainly 24 out of, and they were nice and totaled it for me, 53. Now, again, it said 3 ways, so I'm going to say that's equivalent to 0.4528. And that was some crazy decimal, but I'm going to leave it at that. Or 45.28%. Easy enough? Part B, find the probability that a person selected would, I want you to circle this word not, they threw that in there, not prefer Pop A. Okay, so as I'm looking at this table, I'm saying I would not want Pop A. I'm going to kill that one. That means I would either want B or C. So I'm going to say that's a total of, let's see, what is that, 35 out of 53. So did you catch that? I'm saying I don't want Pop A. That means I could want B or C. So 35 divided by 53 gets me a 0.66037 as a decimal, or 66.037 as a percentage. Well, hopefully that was a nice little warm-up on probability for you. And like I said, this is just the tip of the iceberg here, and we're going to start diving in a little deeper in the next few days. Have a great night, and we look forward to some practice.